Hello everyone, and welcome back to Tech Adventure. I hope you're all doing well and staying dedicated to enhancing your skills in software development and embedded systems. This video continues our C++ interview Q&A series, designed to help college students, freshers, and experienced developers ace their C++ interviews with confidence. Previously, we covered 50 real-world C programming interview questions, key topics frequently asked in interviews. If you missed those videos, I highly recommend checking them out for a solid foundation before moving forward. If you find this content helpful, like, subscribe, and share to support the channel and help others on their learning journey. Let's dive and continue our Q&A series on C++. 41. What are difference between pass-by-value, pass-by-reference, and pass-by-pointer? Let's break down the differences between pass-by-value, pass-by-reference, and pass-by-pointer. These are three primary ways to pass arguments to a function. 1. Pass-by-value. A copy of the actual value is passed to the function. Changes made to the parameter inside the function do not affect the original value. 2. Pass-by-reference. A reference to the actual variable is passed to the function. Changes made to the parameter inside the function affect the original variable. 3. Pass-by-pointer. A pointer to the actual variable is passed to the function. Changes made to the value pointed to by the pointer affect the original variable. 42. What is the difference between STD, atomic, and volatile? While both STD, atomic, and volatile are related to multi-threaded or low-level programming, they serve very different purposes. Here are key differences: STD, atomic versus volatile. In summary, use volatile for hardware-related variables and STD, atomic for thread-safe operations in concurrent programming. See the examples how they have used. 43. What are major differences between C++ 11 versus 14 versus 17? The evolution of C++ from C++ 11 to 14 and 17 brought several enhancements and new features. Here's a summary of the major differences. In summary, C++ 11, major overhaul with new features like auto, lambdas, smart pointers, and concurrency. C++ 14, refinements and minor additions like generic lambdas and relaxed Constexpr. C++ 17, further enhancements with new libraries, parallel algorithms, and structured bindings. Each version builds on the previous one, adding more capabilities and making the language more expressive and efficient. 44. What are Constexpr functions, and how are they different from inline functions? Constexpr functions. Constexpr functions are functions that can be evaluated at compile time, if their arguments are constant expressions. This allows for optimizations and guarantees that certain computations are done during compilation rather than at runtime. Inline functions. Inline functions are functions that the compiler attempts to expand in place, where they are called, rather than generating a call to the function. This can reduce the overhead of function calls, but does not guarantee compile time evaluation. In summary, Constexpr functions are about compile time computation, while inline functions are about reducing runtime overhead. Inline and Constexpr can be used together. This gives the compiler freedom to both evaluate at compile time and inline the function. See the example. 45. What is circular references that can occur when using shared pointer? Circular references are a common pitfall when using shared pointer in C++. A circular reference happens when two or more shared pointer instances refer to each other, creating a cycle. Because shared pointer uses reference counting to manage memory, this cycle prevents the reference count from ever reaching 0, so the memory is never released, causing a memory leak. To avoid circular references, you can use weak pointer for one of the references in the cycle. Weak pointer does not contribute to the reference count, thus breaking the cycle. 46. What is the difference between a normal function and a lambda function? Both types of functions have their own use cases and advantages. Lambda functions are particularly useful for short, temporary tasks, while normal functions are better for reusable code blocks. Here are the key differences. 47. What are move semantics in C++? Move semantics in C++ that allow the efficient transfer of resources from one object to another rather than copying them. This is particularly useful for optimizing performance when dealing with temporary objects or large data structures. Key concepts of move semantics. 1. R. Value references. R. Value references are a type of reference that can bind to temporary objects, or values. They are declared using %. 2. Move constructor. A move constructor transfers resources from one object to another, leaving the source object in a valid but unspecified state. 3. Move assignment operator or copy constructor. Similar to the move constructor, the move assignment operator transfers resources from one object to another. Move semantics are a powerful feature for optimizing performance in C++ applications. 48. Explain the rule of 5 in C++. The rule of 5 in C++ says, if your class manages a resource, like dynamic memory, file handles, etc., and you define any one of the following special functions, you should usually define all 5. The 5 special member functions are 1. Destructor. 2. Copy constructor. 3. Copy assignment operator. 4. Move constructor. 5. Move assignment operator. These manage copying, moving, and cleaning up your class's resources. See the summary here. 49. What is return value optimization? Return value optimization, RVO, is a compiler optimization technique in C++ where the compiler eliminates the temporary object created to hold a function's return value. Instead of creating a copy of the returned object, the compiler constructs the return value directly in the memory location where it will ultimately reside. With RVO, no temporary object is created, no copy or move constructor is called. Boosts performance by eliminating unnecessary operations. A related optimization is named return value optimization in RVO, which applies when the return value is a named variable within the function. The compiler can still optimize the return to avoid unnecessary copies. RVO and NRVO are powerful optimizations that modern C++ compilers often apply automatically, making your code more efficient without requiring changes to your source code. 50. Where is a move constructor used in C++? A move constructor is used when an object is initialized from a temporary object or value, allowing the transfer, move, of resources instead of copying. This is especially useful for classes that manage dynamic memory or other heavy resources. Here are some common scenarios where a move constructor is beneficial. Returning objects from functions. Efficiently transfer resources to the caller. Passing and returning temporary objects. Avoid unnecessary copying. Optimizing container operations. Improve performance of standard library containers. Avoiding deep copies. Transfer ownership of dynamic resources. That wraps up this series on real C++ interview questions and answers. We've covered the top 50 questions commonly asked in interviews. If you prepare well with these, you're definitely on the right track to acing your C++ interview. If you found this video helpful, don't forget to like, share, and subscribe to the channel for more content on software development and embedded systems. For a diverse experience, I also encourage you to subscribe to my other channels. Link has provided in description. We'll continue this learning journey with more upcoming topics, including popular interview areas like solid principles, design patterns, and embedded system perspectives such as RTOS, microcontrollers, and communication protocols, all with real-world interview Q&A. Good luck with your preparation, and see you in the next video.